So the last time we did a lesson, we talked about standard form of equations and slope intercept form of equations and how to graph those things, right? And today, what we're talking about is writing linear equations. We can write any linear equation as long as we have either 2 points or a point and a slope, right? Because if I have 2 points in that line, right, on the graph of that line, I can find the slope of the line. And if I have a point and a slope, we can use something called the point slope formula. And the point slope formula will allow us to take a point and a slope. Like, see how creative we are in math? Like, slope intercept form has a slope and an intercept. Point slope formula takes a point and a slope, and it allows us to create the equation of a line in slope intercept form, right? Which is what we're always trying to get to. That y equals mx plus b is where we're always trying to go with these linear equations. But we have this thing called the point slope formula, and it is y minus y1 equals m times x minus x1. Now, m, whoops, look at me making a mess. This is the one thing I don't like about this. The eraser on my pen doesn't erase. I have to like come up here and click the erase button and then touch that. And then to erase the next little piece, I have to do it again to erase that. Kind of lame. So m, just like with mx plus b, is still the slope, right? This y1 and x1 part right here, those are just any point. So if I have any point that's on that line, right, all our points have an xy value, right? We get those coordinate points where we have like an x value and a y value that we can graph. Well, our x1, y1 is just what we're calling any point we want that's on that graph. And all we have to do if we have a point and a slope is plug it into this formula, right? And when we solve it out, we will have that y equals mx plus b form. So we'll have written the equation of the line. So as long as I have at least 2 points or I have a point and a slope, I can write the equation of any line. So I'm going to kind of take you through that process right now. Starting with a point and a slope, because a point and a slope is a little easier to find. All the work's already done, right? So oops, went a little too high. We want to keep that formula in there. So if I am given a point and a slope, if I can make this thing work properly, if I am given a point and a slope, so say my point is negative 1, 7. And then I also have a slope, my m equals negative 4, right? So I have a point and I have a slope. And if you notice the point slope formula, where I can plug in is the slope and this point. So if I take this point and slope, I can plug it in for my, let's go green. I can call this, oops, sorry, x1 and this y1, right? Because I can call any point that I have that's on that line x1 or y1. I can pick any one that lands on that line. The only one we know of is the one that they're giving us, right? So I'm given a point and a slope, and I'm going to be asked to write the equation of this line. Well, I have this formula here to do that. So I have a point slope formula. So I'm going to go y minus y1. Well, y1 is just 7 equals m. Well, we're given our m, right? That would be negative 4 times x minus x1, right? That's what we're seeing up here. So minus x1, well, that's negative 1. Notice that I put in the negative because it reminds us that it's minus minus, which becomes plus, right? So this would become a plus 1. And now all I have to do is solve this out. So I have minus 7 equals, well, negative 4 times x is negative x. Negative 4 times plus 1 is negative 4. And I'm almost there, right? I'm almost in that y equals mx plus b form. Look, I forgot to write the 4 here. Nobody told me. Minus 4 times x is minus 4x, right? The only thing I have left to do is to move this 7 over, right? So I'm just going to add 7 to both sides. And I'm going to have y equals minus 4x. Minus 4 plus 7 is plus 3. And we've written the equation of this line, right? All we did was plug in the slope and plug in the point and then solve it for y. That's it, right? Plug in point. Plug in slope. Solve for y. Right? And once we do that, it puts it automatically into that slope intercept form. I mean, if we looked at this problem, we should be able to graph it, right? Because what do I know? I know I have a slope at negative 4, and I have a y-intercept at 3, right? Because that's what this tells us. This and y equals mx plus b, this is our y-intercept. And this right here is our slope. And so we can graph this line, which is why slope-intercept form is such a useful form. That y equals mx plus b is super useful to us. And when you're given a point and a slope, it's super easy. And we'll do one more that looks like that. And then I'm going to move on to one with 2 points to see how we get there in the same respect. So what if I'm given an example where I get a point of negative 6 and negative 5, and I have a slope of 2/3. Yeah, that kind of looks like a 3, doesn't it? I'm going to do the same thing. I'm going to take that point slope formula, slope formula, the y minus y1 equals m times x minus x1. And I'm just going to plug things in, right? This is going to become x1. This is going to become y1. We already have our m in place, and we're just going to plug it in. I have y minus y1. Well, that's minus 5 equals m. Well, that's 2/3 times x minus x1. Well, that's negative 6. Immediately when I look at this, I can go, okay, so this becomes plus 5, this becomes plus 6, because I have the negatives together, right? That negative. And when I go to solve it now, I can go y plus 5 equals, well, when I distribute this, I get 2/3 x. And here I'm going to get 2 times 6 is 12. 12 over 3 is just 4, right? The only thing I have left to do, this fraction doesn't mean anything to us right now because all I have to do now is subtract 5 from both sides, and I don't need to combine it with that fraction because there's no x in it. It's not a like term. And we get y equals 2/3 x minus 1. 4 minus 5 is -1. And this is the equation of our line. And it allows us to easily graph this equation. So we didn't just write the equation of the line, we wrote it in a form that makes it really easy to graph, right? Because it's in that y equals mx plus b form that we did earlier this week. But what happens when we aren't given a slope? What happens when all we're given is 2 points? Let me do that so you guys can still see what was going on down there. So if I'm given a slope and a point, it's really easy, right? Because we just plug those in to the point slope formula, right? Which I will write again. I'll write it 1,000 times before the end of today. Maybe 1,000, right? Which is our y minus y1 equals m times x minus x1. And so when we're given the m and we're given that x1, y1 point, it's fairly easy, right, to know what to plug in. But what if we're given 2 points? What if I'm asked to write the equation of the line given 2 points? So if I have -6, 1 and -3, 7, and we want to, that's a 7, write the equation of the line. So when I look at this, I go, okay, well, it's easy to come up with a point, right? I've got 2 of them. I can use either one for the x1, y1. Doesn't matter which one I pick. The problem is I don't know what m is, right? I don't know what that slope is. So we would have to use what we call the slope formula. And I know you guys have used it before, but what it basically is the difference in our x's, the differences in our y's over the differences in our x's. So m equals y2 minus y1 over x2 minus x1, right? The differences in our y values over the differences in our x values. Now, which one of these points I call x1, y1 doesn't matter. As long as I make one of them x1, y1 and the other one x2, y2, it doesn't matter which one I choose, right? To be what? They're just arbitrary. It's just saying 0.1 and 0.2 and 0.3 so that we know, like, to keep those things in kind of order, right? So if I have my y2 is 7, this would be 7 minus my y1, which is 1, over x2, which is -3, minus my x1, which is -6. So 7 minus 1 is just 6, over -3 plus 6, right? I had that negative, which is also 3. And since 6 over 3 equals 2, I now have my slope. My slope, my m, is equal to 2. And so now I can go ahead and plug this into that point slope formula, right? I have my m, which is 2, and I can use either one of these points when I'm plugging it in now. So here I go, okay, well, y minus y1 equals m times x minus x1. I can call either one of these points x1, y1. I already have this one labeled as x1, y1, so I'm going to go ahead and use that one. But it doesn't matter. I could use the other one. It's still going to give me the same equation of the line. And we know what our slope is now, so it's just 2. So I'm going to go y minus y1, well, that's just 1, equals m, which we know is 2, times x minus x1. And our x1 is negative 6. And when I put these two together, it becomes a plus. And now I can go ahead and just do my distribution and solve for y. So for right now, we'll leave the y minus 1 alone. And we'll go 2 times x is 2x. 2 times 6 is 12. And the only thing I have left to do is to move this minus 1 over by adding 1 to both sides. And I get y equals 2x plus 13. So the really big difference, I don't even want to say the difference. The whole idea is that we can go from one step to the next. Anywhere we have, like whether we've got 2 points or a point and a slope, we can always find the equation of the line, right? One comes before the other. The first thing we need is the slope. The next thing that we need is the point slope formula, right? And then the next thing that we need would be putting it into slope intercept form. So you can kind of see that there's this little process that we follow. I don't know why it's not letting me move down on this thing a little bit. There we go. So, because I like to think of things in terms of steps, like where am I with this? So the least thing that you can have is 2 points, right? If you have 2 points, find the slope, right? If you already have a point and a slope, you can go right to that point slope formula. Right? And then the next thing you do is solve, let's call that for y, and that gives us slope intercept form. Now, is it confusing? A little bit. Like if I have 2 points and I need to find the slope, I need that slope formula, right? That m equals y2 minus y1 over x2 minus x1, right? We definitely need to know what the point slope formula is, that y minus y1 equals, you ever notice like when I do it in slope form, I write my y's that way, and when I do point slope formula, I write them a whole different way. I don't know why that happens. It's just weird. X minus x1, right? So if I have anything along that line, as long as I'm starting with at least 2 points, I can find my slope. And if I can find my slope, I can use point slope formula. And if I can use point slope formula, I can get it into slope intercept form. And then I've written the equation of the line. I'm going to do one more example of the 2 points, and then I'll do like one of the word problems, and then I'll let you guys go. Orange, I'm into the purple and orange these days, and I think it's because it's almost Halloween. So let's look at Our next example would be a given 2 points. Let's go 10, -5, and 1, -8. So first thing I need to do is I need to find that slope, right? I have 2 points, so I can use either one of those, but I need to find the slope. So I'm going to call this x1, y1. I'm going to call this x2, y2, and I'm going to plug it into my slope formula, which is y2 minus y1 over x2 minus x1, and I'm going to get minus 8 minus a -5 over 1 minus 10. This becomes plus, and I get minus 8 plus 5. Well, that's just -3 over -9, right? 1 minus 10. Negative over negative is a positive, and when I reduce this fraction, I have a positive 1/3. So I have m equals 1/3, and I can use either one of these as my point, right? So now we have a point and a slope. So we could go to the one that asks for a point and a slope, which is the point slope formula, or y minus y1 equals m times x minus x1. And we could just plug it in. So y minus y1, well, y1 is just -5, so minus a -5 equals m, which is 1/3, times x minus x1, well, that's 10. And now we're just going to solve that out. This becomes a plus. I'm going to leave it alone for a second. Y plus 5 equals, distribute, 1/3 x minus, well, 10 times, -10 times 1/3 is just minus 10 over 3. This one's going to be a little uglier because when I move this 5 over, I'm going to have to find a common denominator, but we are adults. We can work with fractions, right? We could do this. And I know every time I say that, people are like, yeah, speak for yourself. We hate fractions, but that's okay. So here I have y equals 1/3 x. And now I have this minus 10/3 minus 5. So if I think about this, minus 5, I need a common denominator. Minus 5 is 5 over 1. So our common denominator is just going to be 3, right? So I'm going to multiply this right here times 3 over 3. -5 over 3 is just 15 over 3. So ultimately what we have is minus 10 minus 15 thirds, which is minus 25 thirds. I don't need to deal with anything over here, that fraction, right? I just need to do it with the part that combines, which is that 5 and the minus 10 thirds. This does not reduce, right? 23 does not go into 25. There's nothing that I can multiply 3 times to get 25. So this fraction is as reduced as we're going to get it. We never want to use mixed numbers anymore. We don't worry about turning things into mixed numbers anymore. That's from middle school. This is high school. We don't care about mixed numbers. But that's like the last example that I'll give you in terms of how to write these equations. Not ever, like if you needed more down the road, you could. But what I want to talk to you about a little bit is the word problems that are going to be on your sheet. So you're going to get problems that are kind of like, not even kind of like, exactly like, you're going to be given, people panic with word problems, right? But you're given every piece of information that you need when you're given a word problem. So pull it out and forget the words after that, right? So say I get my pen to work. Say a cab ride, because we do so many taxis around here. A cab ride costs $4 plus $1.75 for every mile. right? And we want to write an equation to represent the cab fare. So the first thing we would want to do is define our variables, right? We would want to go, okay, well, let's say C equals cab fare, because that makes sense, right? And we'll say that M equals miles, because that makes sense too, right? And so basically, we want to write this equation that no matter what, we could figure out how much we'd be paying based on the number of miles, right? So I could say that the cab fare is going to equal, C is going to equal, well, $4, right? Plus $1.75 times M, right? Oops, $1.75 times M, not. So that's all I have to do in respect to that. So if I wanted to continue with this word problem and say, okay, well, I want to go 17 miles, right? I want to go 17 miles and I have $30. Will I make it? Do I have enough to get there? So, I mean, we could kind of like think about this a little bit and guess, but we could just plug it right into the formula, right? We have this formula that tells us how much something's going to cost based on the number of miles. No matter what, I got to start off paying that $4. So let's see what this cab fare is going to cost us. We have C equals 4, because no matter what, we got to pay at least $4, plus $1.75 per mile, right? Per M. But we know that our M here is 17. Now, I can't do this math in my head, but I know that this is going to be 4 plus, I already did the math, 29.75. So right away now, I know not going to make it, right? I got to look at that 29.75. This is going to be 33.75 when I add it together, and I can go, okay, I don't have enough money to go 17 miles, right? So my answer would be no. All your problems are going to kind of be like this. You're going to be given these two variables, and you're going to have to be, you're going to kind of want to think about how you're going to pull these pieces out. You are not excused from the word problems on it. I'm not having you guys do the linear regression stuff, but you guys do have to do the front part of the page where you have word problems. I'll bring it up really quick so that you can see what I'm talking about. So when you look at this, these linear equation applications you have to do, all of this, right? But you don't have to do the 9 and 10 stuff. So you do have 8 word problems that you have to do. It's a lot of word problems. I don't normally assign that many, but I think you guys can handle it. Show your work on the paper if you want it to count. Ask for help if you need it. And other than that, does anyone have any questions? Lance is not. I appreciate that. The only one who makes me feel like I'm actually talking to a human being sometimes. You don't know how much I appreciate that. All right. Well, if you don't have anything for me, go away. Have a good weekend. You too. Thank you. Thank you. I kind of do like the new whiteboard, but it's going to take some adjustment. I think I'll like it a lot more once, when I'm bringing stuff into it. Um, but it just like all of those things, when you're writing on a computer, it takes time to get used to. Did you like it? Yeah, like if I wanted to, like if I was going to help you with homework or something like that, I would bring your homework sheet right onto it and solve it on the form, which is kind of cool. So I like that, and I can bring graphs into it if we want to graph stuff. So I do really like that. You too, Dylan. Haiti, Rodolfo, did you guys have questions, or did you fall asleep? That's a no. All right. All right. Have a good one. How about you, Haiti? You good? I think she fell asleep. Why am I still recording?